Okay, continuing from the previous video, importance of software engineering. Like I was saying earlier on, we've spoken about this earlier. First is to reduce complexity. Of course, it's not as if the software is not still going to be complex, but to reduce the complexity of the development process, so as to make the development process smooth, minimize software cost. Yes, so that we won't spend too much, we won't under budget, we won't over budget, we just will be able to just get the exact value for our money that we're putting into the development of this particular software. Decreases time. Yes, one thing, like I told you, I've given you an example of a software product that they were only trying to upgrade until now. They couldn't get this upgrade done for close to 20 years. Not because they don't have good programmers, but because they could not just manage the process. Each time some software developers come on board, those ones will work a little. At some point, they will dump it. And that sort of people will come, they will dump it. Just kept on like that. And at some point, even the owners of the software got tired. Also, handling of big projects. An example of a big project, if you will know, is as maybe to you trivial as your SSUB. Your SSUB is actually not a small project. Your SSUB is a very big project. It's a project that will live after all of us. It just cannot stop. Of course, there are some projects that you can feel as simple, as small. Yes, you guys can think about. But of course, the very, very, very big ones, you could start speaking about the Googles of this world, the Facebooks of this world, the Twitters of this world. But then, even if those ones were so big that you may not really be able to relate to those ones in terms of the complexity, but even your SSUB is not a small project. Reliable software. Of course, you don't want a software that will keep failing. You don't want software that results are inconsistent. You don't want a software that is always having downtimes. That's what we mean by reliable software. That's one of the reasons why software engineering is important. Effectiveness. You want a software that does exactly what you want it to do. If you download apps on Play Store a lot, you see reviews. And of course, I came across one of the softwares. I was personally disappointed in. I'm not going to mention the name, but let me just continue. In fact, when I read the reviews, I thought maybe people just wanted to put this software down. Maybe people just didn't like these people or something. I decided to download this software myself. And the very first annoying thing was, I've never used it before. I've always heard of this software and I really wanted to just try it out. And would you believe, the moment I downloaded the software and it was asking me to register, and I put in my details, it told me that I'd registered before. Of course, I'd never been registered with them. That my phone number, my no phone number is already registered with them. That was the last time I bothered myself trying to use that software. I was annoyed. I'd never used their software. So how come they could tell me that my phone number, which is of course, if somebody has put in a fake phone number, maybe just to circumvent some things, and I put my phone number, there should have been a verification. They should have sent a message to me to verify that, oh, are you the one trying to register on our app? They never did any of that. Effectiveness, reliability, those two are very, very, very important. Especially if we are talking about apps that has to do with almost every app nowadays has to do with has user information. And that is the basis of where cybersecurity comes from. Social engineering, once it gets even as little as your email address, as little as your phone number, the process has started. And before you know it, somebody will call you and start telling you it's from one bank and they want to upgrade your ATM or something. And if you are not careful, one will fall a victim of such. So these are the reasons why software engineering is very, very important. Now, What is software processes? What do I mean by software processes? Now, software processes can be regarded as the methodology of creating this software, the methods, the activities that are associated to the outcome of producing the software. These activities may involve the development of a software from scratch or modifying an existing system. It involves dividing the software into smaller phases. Now, software engineers are the ones that carry out these processes. So what are these processes? We have 4 main processes. Number 1, software specification. Now, we can look at that. To get software specification, we need software requirements. We need feasibility. Feasibility in terms of, is this software, we'll still get into feasibility soon enough when we get to, there's still feasibility. But we'll talk about the various types of feasibilities. Even if a software is not feasible, feasibility does not necessarily mean that will this software work. No. For example, let me give you, there's one aspect of feasibility that we know that is called legal feasibility. For example, most time when we say feasibility, what we always look at is technical feasibility. Can I do it? Yes, you can do it. But what about legal feasibility? That's another aspect of feasibility. So if somebody now it's something I've faced before. Somebody once approached me that, I need a software where that will look like a bank software. It's not a bank software, but it will look like it, and will try to deceive people into putting in their details into this software, and from there we probably get their ATM pin and scam them. Technical feasibility, can it be done? Yes, of course. I'm a developer, I can do it. Legal feasibility, should it be done? No. Should it be done? No. So that's an aspect. That all goes into specification. What do you need the software to do? Development. Now, development comprises of 2 things. I said specification comprises of 2 things. Number 1 is requirements and feasibility study. Second one is development. Development now is a combination of 2 things. Also, design and implementation. Implementation means your coding, which is the actual process of writing out your program. Validation, testing. In fact, you cannot stop. Something we've always shouted. Testing. You cannot just leave it out. It's something but of course, that is just for small developers. We are talking of big time developers. They don't joke with software testing because they know the implication. It can ruin your software forever. Software that you've spent millions of naira or millions of dollars to develop. Just one tiny error can be what will end that project. Evolution. Now, evolution will not, because evolution of software will never stop, because there will always be changing user needs. Human needs are insatiable, like we were taught in economics, and it always changes, it always evolves. So therefore, the software that is used by human beings, even if at the end of it, everything is being used by human beings, even the so-called software, system software. If there's not a need for human beings to use computers in the first place, there won't have been a need to create application software. So it must also always evolve. That's why we still always have new versions of Windows, new versions of Linux, new versions of Mac OS. So now, software models. Now, I call this software models, but we're still going to revisit this later on. So maybe I should let's leave it as let's just say types of software models, so that you won't confuse it with something that we'll be doing in the next class or in 2 classes time. So we have 2 types of software models basically. Number 1 is the workflow model. Now, workflow basically shows the activities of this software with their inputs as they move from one part of the software to another. The activities in this model perform human actions. What are the actions that should be performed? Examples of this is workflow diagrams are examples of it. Another type of another one is you can call your flowchart, your basic flowchart, the one you learned about, is also a kind of workflow model. Basically shows the flow of work. Then data flow and activity model. Now in data flow and activity model, we're trying to this represents the process as activities. Each carries out some data transformations. Now, how we convert our data from place to another activity to another, and within our software must be shown. Now, example of this is our data flow diagrams and our activity diagram. We will be designing some data flow diagrams and activity diagrams later on in the course of this lecture, not today, and another lecture because of this class. So, we also have role and action model that shows the people and what they can carry out on the software. And the perfect example for that is what we call the use case diagrams. So, classification of development lifecycle. So we have two classes of software development lifecycle. Number one is called the predictive approach. Number two is called the evolutionary approach. Now, the predictive approach tries to prescribe the various stages for us. Now, once we finish one, we sign off, we move to the next stage. Once signing off that, we move to another stage. Of course, the waterfall model is waterfall model is still the basic example of this. We'll see more on this later on. But there's another approach called the evolutionary approach. Now, in the evolutionary approach, we are not particularly about designing the entire system at once, but we want to design the system in releases, versions, little by little, till we get to the ultimate goal. Those are called evolutionary approach. We'll see them in the next class. Currently in the world, there's something called the software crisis. What do we mean by software crisis? Number one, size. Software becoming more expensive and more complex with growing complexity and expectation out of the software. For example, the code in the customer product is doubling every couple of years because with the advent of mobile phones, ubiquitous computing, pervasive computing, and the likes, there's a need for software. There's a software explosion, so that almost everything is being turned into software. Almost everything you need to do. Lectures, of course, I'm using a software to record this lecture. The last time I visited a bank, I don't even know. Last time went inside a bank. The only thing I do is visit ATMs. But so enter a bank, and of course, I have softwares, my banking software to do that, all of that for me. Quality. Now, because of that, the quality of software has improved. The expectation has improved. Of course, with the advent of artificial intelligence also, what your software does has improved. Softwares are now more intelligent, so the quality is improving. Many software products have poor quality. The software product defects after putting into use due to ineffective testing. I've mentioned that. Costs. Of course, software development is costly. Nowadays, it's what we always shouted a lot in your class. Software engineers currently, not software engineers, software developers. Of course, software engineers are also earning quite well, but currently, software developers, even in Nigeria, are earning between 350,000 naira to 750,000 naira in a month. I'm talking of even just you know how to do it, you can do it, you have some experience in doing it, you are earning 350,000 naira. So, of course, they are not paying you to just be collecting the money. You are supposed to deliver a software, and you have to deliver it. So, all of that goes to the cost of developing the software. Delivery, like I've mentioned it when I was talking about the app I told you that they've been doing it for almost 20 years, not because they don't have good people, but just because they have a lot of bureaucracies. Well, that's their problem actually. But back to the class. There should always be schedule. If you run out of schedule, if you spend too much time, then you're spending too much money. So your software must be developed within a time frame. So all of this is known as the software crisis. We want the software, one quality, of course, is expensive and must be done to time. So this software crisis is one of the reasons why we need software engineers. I think I need to also pause again and continue in the next class.